So this is triangle ABC. Here we are going to discuss isosceles triangle theorem. So according to this theorem, when a triangle is an isosceles triangle, so for being isosceles triangle, we know that one pair of adjacent sides should be equal and congruent. So in this triangle, AB is congruent with AC. These two sides are equal. If these two sides are equal, then this triangle ABC can be called isosceles triangle. So according to this theorem, theorem of isosceles triangle, we can say that in triangle ABC, angle B is equal with angle C. So these two angles are equal because they are base angles of an isosceles triangle. So this is one of the property of an isosceles triangle, that base angles of an isosceles triangle should be congruent. Look at this. This angle should be equal with this. And what is converse of isosceles triangle theorem? Here, if AB is equal with AC, then it makes triangle ABC as an isosceles triangle. So in that case, if these two sides are equal, so you can say these two angles are also equal. This is called theorem on isosceles triangle, and we have converse of this theorem. If you know that a triangle, in any triangle, if base angles are equal, you can say that the triangle is an isosceles triangle. Suppose if I tell you that we have a triangle, suppose we have another triangle. The name of this triangle is PQR. This is P, Q, and R. And if it is given that angle Q is equal with angle R, so in triangle PQR, angle Q is equal with angle R. Then what you can say? Then you can say triangle PQR is an isosceles triangle. So this is called converse of isosceles triangle theorem, where it is already known that these two base angles, that is Q and R, are congruent and equal. So you can conclude that the given triangle is an isosceles triangle. So this is because of converse of isosceles triangle theorem. And if you know that one pair of adjacent side, any one pair of adjacent side, it could be AB and AC, it could be AB and BC, and it could be AC and BC. So you will get three adjacent pair of sides. If any two of them are congruent, you can say the given triangle is an isosceles triangle. So this is the difference between isosceles triangle and converse of isosceles triangle. So hope it is clear. Now next is 30-60-90 theorem. So we have triangle X, Y, Z, which is a right angle triangle at angle Y. In this triangle, angle X is of 30°, angle Z is of 60°. So in triangle XYZ, one angle is of 30, the other is of 60, and third angle is of 90 degree. So as we know, any triangle where one angle is of 90 degree, we used to call such triangle as a right angle triangle. Am I correct? Yes. So it is right angle triangle. But besides being right angle triangle, there are some more qualities can be seen as there is a pattern in their angles. One angle is of 30 degree, the other angle is of 60 degree, and third angle is of 90 degree. So this is right angle triangle, as well as it is its angles are 30, 60, 90 degree. So if any triangle fulfill these two criteria, means it is right angle triangle, as well as all three angles of this triangle are in such a way that one angle is of 30 and the other is of 60 and third is of 90 degree. So you can use two theorems in on this triangle. First, we have already studied Pythagoras theorem, right? So we are using Pythagoras theorem to solve to find out missing side of a right angle triangle. So since it is right angle triangle, this XYZ is a right angle triangle. So you can use Pythagoras theorem as well. We have 30, 60, 90 theorem also, which we can use in order to find out missing sides. So we will discuss later what is difference between those two theorems which you can apply on this triangle. So why we have the 30, 60, 90 theorem and why we have Pythagoras theorem, that is we will discuss. But before that, I'll tell you what this 30, 60, 90 theorem says. In triangle XYZ, one angle X is of 30 degree. So in that case, I can say that length of YZ is half of hypotenuse, and hypotenuse is xz. Then angle z is of 60 degree. So here I'll say length xy is root 3 by 2 times of hypotenuse, that is xz. So these two things we need to remember. Now come to this. This is first where we mention that length of yz. Length of yz means I am talking about this side. Length of yz is half of xz. Xz is hypotenuse. This is your xz. So question arises, why yz is half of xz? Because when you take this identity in your solution, you need to mention the reason. Why yz half of xz? So that you will mention. Same way, the second part of this theorem says length of xy is actually root 3 by 2 times of hypotenuse. Then again same question arises, why this xy is root 3 by 2 times of xz. Xz is hypotenuse. So always remember, side opposite to 30 degree angle is half of hypotenuse. Remember this statement. This 30, 60, 90 theorem says the side opposite to 30 degree is always half of hypotenuse, and side opposite to 60 degree is always root 3 by 2 times of hypotenuse. So as you can see, this yz is the side which is opposite to angle x. So that is the reason this yz should be half of hypotenuse. Xz is hypotenuse. So here you will mention side opposite to 30 degree. Side opposite to 30 degree. Then here xy is root 3 by 2 times of xz. So xy means this side. So what is length of this xy? So xy is basically side opposite to 60 degree. That is the reason it is root 3 by 2 times of hypotenuse. So here you will mention side opposite to 60 degree. Now we will understand this with the help of an example. I'll give you an example. Suppose you have a triangle which is 30, 60, 90 degree. This angle is of 90. This angle is of 30 degree and this angle is of 60 degree. Now the name of the triangle is ABC. If BC, if BC is of 2 centimeter, find out the length of AB and AC. Or I can make it quite simple. I just want to change this length. I tell you that this AC is of 6 centimeter instead of BC. AC is of 6 centimeter. Find the length of AB and BC. So you need to find out AB and length of BC. Now, so everybody look at this. In triangle ABC, side BC is opposite to 30 degree. So BC should be half of hypotenuse. So this way your BC will become 3 centimeter. And since AB is side opposite to 60 degree, so AB is root 3 by 2 times of hypotenuse. So AB is 3 root 3. Now, as I told you, in 30, 60, 90 theorem, one angle is of 90 degrees, so we can use Pythagoras theorem also, right? So in order to use Pythagoras theorem, what we require and what we can do and what we are doing by using 30, 60, 90 theorem. So we just need to differentiate between those two theorems. Suppose if you have a right angle triangle, as you can see on your screen, A, B, C or X, Y, Z, any one of these two, you have. In case of ABC, I gave only length of AC, right? So this length of AC is known. This length of AC is known as 6 centimeter. And I ask you to find out length of AB and BC. And you did that. You find out BC as 3, AB as 3 root 3. So when we using 30, 60, 90 theorem, if one length of one side of the triangle is given, we can find out other two sides of the triangle by using 30, 60, 90 theorem. Am I correct? But if in any right angle triangle, if you want to use Pythagoras theorem, so we know that in Pythagoras theorem, the square of hypotenuse is equal with the sum and square of remaining two sides and perpendicular sides. So in that case, if you using Pythagoras theorem, you need length of any two side of the triangle. So then you can calculate third side of the triangle. So in order to use Pythagoras theorem, it is important to have length of any two sides of the triangle to find out third side of the triangle. But in case of 30, 60, 90 theorem, if you have length of any one side of the given triangle, you can find out remaining two sides of the triangle. And that is the difference between 30, 60, 90 theorem and 45, 45, 90 theorem. In 45, 45, 90 theorem, if length of one side is given, we can find out remaining two sides. But in order to use Pythagoras theorem, we cannot find out two unknown sides if one side is known in a right angle triangle. So this is the limitations, and that is the reason this 30, 60, 90 theorem can be used even in any right angle triangle to get the length of remaining sides and unknown sides if one side is known, because we cannot apply Pythagoras theorem over there. So you need to make it very clear and remember this thing, that in right angle triangle, if two sides are known, in order to find out third side, we can use Pythagoras theorem. And if in any right angle triangle, if only one, if remaining two angles are 30 and 60 and only one side of the triangle is known, then we can use 30, 60, 90 theorem to find out any two remaining side of the or missing side or unknown side of the triangle. So hope I made myself clear and you have understood this difference between Pythagoras theorem and 30, 60, 90 theorem. And when we going to use these theorems, now let us move on 45, 45, 90 theorem, which is similar to this 30, 60, 90. So third theorem which we will discuss is 45, 45, 90 theorem. So this is triangle ABC. In triangle ABC, angle B is of 90 degree and angle A and C are 45, 45 degree, and this theorem is called 45, 45, 90 theorem. What is mean by this theorem? So I would like to give you a statement. So here you can say AB is equal with BC. Why they are equal, that is important. Just we discuss your first theorem. Look at this. Isosceles triangle theorem. If AB equal with AC, then angle B and C should be equal. So this is basic property of an isosceles triangle. If one pair of adjacent sides of a triangle are congruent and equal, then it is called isosceles triangle, and the base angles of that triangle should be equal, that is B and C are equal. If base angles are equal, then again you can say the given triangle is an isosceles triangle and adjacent sides are congruent, that is AB and AC or PQ and PR, they are congruent. Similarly, in 45, 45, 90 theorem, it is already given that this angle A is of 45 degree and this angle C is also 45 degree. So these two angles are equal and they can be considered as base angles of this triangle. If base angles are equal and congruent, then we can say triangle ABC is an isosceles triangle, and it is right angle isosceles triangle. So where AB is equal with BC. This is basic property of an isosceles triangle, that base angles are equal. That's why AB and BC are also equal, and triangle ABC becomes an isosceles triangle. Now, So ABC is a right angle isosceles triangle where AB is equal with BC, and what this theorem says, AB and BC should have same length, that is 1 by root 2 times of hypotenuse, and your hypotenuse is AC. So this is according to 45-45-90 theorem. That